Hello guys and welcome back to Maths with Cats. So today we're going to go over partial fractions. We're going to continue the theme of cats every other slide just 'cause I think it's a fun little extra. So let's get on with some partial fractions. But first, our first cat of the day. So, waiting for the slide to load. There we go. Rules for partial fractions. So the first thing with partial fractions that's really important to know is the general rules about them. Otherwise, because that's the first step you need. So here we have ax plus b divided by cx plus d ex plus f. This can be written as a number over cx plus d plus another number over ex plus f. We're representing these with capital A and capital B, and in the numerator of the first one we used lowercase a, lowercase b, so that tells you that they are different numbers. So this could be 2x plus 5, and this could be 3 and 9. So different numbers that are used here compared to here. The cx plus d, ex plus f, same, that's why they're still lowercase. Next one, a over bx plus c dx plus e fx plus g can be written as capital A over bx plus c plus capital B over dx plus e plus capital C over fx plus g. Once again, different numbers to what was used in the first fraction. Ax plus b over cx plus d squared ex plus f can be written as capital A over cx plus d squared plus b over cx plus d plus c over ex plus f. With this one, it's important to note that you have to include a cx plus d squared and the cx plus d, even though only cx plus d squared is included in the original fraction. I can't explain to you why I can explain it to you, but I'll explain it to you later on to make more sense when I'm explaining a question with it. But yeah, so these are the general rules that you need to know. You use them right at the beginning of the questions, so it's worth making a mental note. To be fair, most of the time I don't even have to think about these at this point. I just kind of know them. Cats. Okay, let's wait for it to load again because it's being very slow. Hello, Mr. Laptop, are you going to load the next slide, please? Okay, next example. Express 7x minus 1 over x minus 3, x minus 1, x plus 2 as partial fractions. So, from the last one, we learnt that, I don't know why I've gone back to go to the other slide because this is going to go slow. Okay, so we've learnt that something in this form can be written like this. Now, I'm saying like this because obviously we have this numerator and this denominator. So we'll show you in a second when I get back to where I was up to, because I was stupid and said to go back when I shouldn't have. I should have just stayed where I was up to. So this can be written as a over x minus 3 plus b over x minus 1 plus c over x plus 2. So from here, we're going to times up by the denominator, times by the denominators on the top and bottom to get this denominator. So here, we're going to times this one by x minus 1, x plus 2 on top and bottom, this by x minus 3, x plus 2 on top and bottom, this one by x minus 3, x minus 1 on top and bottom to get something that looks like this. So here's me showing how I've got there, and then this is it after I've expanded the numerator. Then you go, well, hang on a minute, the denominators are the same, so we can just work with the numerators. And then when I've written it as the numerators, I've just grouped the x squared terms, the x terms, and the number terms, because you will want it like that, because we're going to equate coefficients. There is another way of doing this. It makes not much sense to me, but equating coefficients does. Might be because we use equating coefficients in further maths. So, all the x squareds on this side must add to give the x squared on this side. Well, the x squared term on this side is 0. So we're going to end up with 0 is the same as a plus b plus c. The sum of the x terms on this side must equal to the x term on this side. So that is going to be 7 is the same as a minus b minus 4c. And the sum of the number terms on this side must add to give the number term on this side. So minus 1 must be the same as minus 2 minus 6b plus 3c. Now you're going to solve these simultaneously. You can do it by hand, much easier if you use your calculator. I don't have my calculator with me right now, but I know I had the Class Whiz, and the Casio Class Whiz. If you use that, you can go mode, and I think it's polynomials, then simultaneous equations, then three unknowns for this one, and then you're going to type these in as the letters. Now, it'll be like in terms of X, Y, and Z. Also, we have A, B, and C. But if you know that your A is the X on the calculator, your B is the Y on the calculator, and your C is the Z on the calculator, it doesn't matter. So long as you make sure you're using the same letters for the same letters. Okay, so then you're going to solve it, and you get A equals 2, B equals minus 1, C equals minus 1. So from there, you then have to actually answer the question and write it as partial fractions. So that's what I've done here. I've written the thing they gave us at the beginning is identically equal to, and then I've subbed these letters in to this up here to write it as partial fractions. You could here take the minus out and put it in front. I was always taught to do it like this because quite often the question will tell you to put it in like this sort of form. Like write it like that. So to write it like that, you need the pluses in between. Yeah. Okay, we're going to go on to another example now when it decides to load. Express 12x plus 6 over 4x squared minus 9 as a fraction. So with this one, we have to factorize the denominator. So we're going to get 2x plus 3, 2x minus 3, difference of two squares. And then that could be written as a over 2x plus 3 plus b over 2x minus 3. This is the same as a lots of 2x minus 3 over 2x plus 3, 2x minus 3, plus b lots of 2x plus 3 over 2x plus 3, 2x minus 3. Times it up on top and bottom to get the denominator over here. So we'll then multiply out the numerator and get rid of the denominator because it's the same on both sides. And we get 12x plus 6 is the same as 2ax minus 3a plus 2bx plus 3b. Again, we'll put the x terms together and the number terms together, and then equate coefficients. So the x term on this side is the same as the x term on this side, so we get 12 is the same as 2a plus 2b, and the number terms on this side must be the same as the number terms on this side, so we get 6 is the same as minus 3a plus 3b. So then solve those simultaneously and we get a equals 2, b equals 4. So, write them as partial fractions and we get this. Waiting for it to load again. It really struggles to get past the cats. There we go. Express 5x plus 12 as partial over x squared, x minus 3 as partial fractions. So that is going to be the same as, and this is where we use the x squared and the x. So basically, the reason why you have to split it like this is so that you get x squared terms and x terms and number terms to solve it with. Because we know that 1 doesn't equal 0, but I'll explain it in a second. So we get this when we multiply up to get the same denominator. Then we can times out the numerator because the denominators are the same. We can get rid of them. So basically, the reason we used the x squared and the x is so that we ended up with an x squared term on the top. We needed that to help us solve it because it's the only way we can solve it. I know why we have to do it. I just can't explain it. So the x squared term on the left hand side is 0, so that must be equal to b plus c. and the x term on the left-hand side is 5, must be the same as a minus 3b, and the number term on the left-hand side is 12, and that must be the same as minus 3a. We then solve them simultaneously, and we end up with a equals minus 4, b equals minus 3, and c equals 3. So 5x plus 12 over x squared lots of x minus 3 must be the same as minus 4 over x squared plus minus 3 over x plus 3 over x minus 3. Yeah! Okay, so that is the end. Sorry for some of the poor explanations. Also, I apologise for my voice. I've had a really bad cold, so it doesn't sound the best at the moment. I hope you enjoyed these videos. Now, I was wondering, don't know what anyone thinks about this, or if anyone's going to answer this question because I don't have very many viewers currently. Does anyone want me to film my results day when I get my results, and also some moving in stuff when I eventually go to uni, things like that? Is that something that people would be interested in? Because I'm perfectly happy to do that. Also, sorry if you've heard my cat story in the background. I don't think you will have, but she sat behind me, so quite possibly. Okay, hope you enjoyed the video. Bye bye!